This video is going to be your notes for in class today, since I'm not here in class. Okay, and in this video we're going to go over 3 things. We're first going to go over domain and range, which we talked about last class. And then we're also going to introduce a new concept, and that is going to be something called end behavior. Okay, you do want to make sure that you have the handout that goes along with the notes, and then as you watch your video, you're going to go ahead and fill that out, and then I'd like you to submit a picture of your notes onto Classroom as proof that you did participate today in class by taking notes. Okay, so I'm going to go ahead and get started. Okay, first 2 examples will just be kind of going over domain and range again. So first of all, domain, recall, is looking at all the x values of a graph. Okay, when we're talking about x values, we're going to be starting at the left and then going to the right. Okay, so as I look at my first graph here, on the left, there's an arrow here, and it's going to continue on. I can see that there is no endpoint for the left of my graph. It's going to go to negative infinity. And then on the right, something similar is happening. It's going to continue on to positive infinity. Okay, so for this one, the domain is going to be from negative infinity to positive infinity. Okay, and if we wanted to write that using inequality notation, we would say negative infinity with x in between, positive infinity, and then we put our less than signs just like that. Okay, so that's the domain for this first graph. And then the range, remember now, is going to be all the values for your graph. So when we're talking about y values, we're starting at the bottom and going to the top. Okay, so looking at this graph, we want to know what is the lowest that the graph goes. Okay, well, since these arrows are pointing downward, we know that the graph is going to start down at negative infinity. It does not have a stopping point in the downward direction. So the range, starting at the bottom, starts at negative infinity, but then it stops right here at this point right here. So we can trace onto my y-axis. Looks like it stops at 1. So my range is from negative infinity all the way to 1, and the 1 is going to be included. Okay, now if I look at my second graph, starting off with the domain. So leftmost point that my graph goes to, well, it's got an arrow here pointing off to the left, so it's going to start off at negative infinity. And then if I go to the right, I see it seems to stop right here at 4. So we would say that our graph here for the domain goes from negative infinity all the way up until 4. Okay, and then for our range, okay, so range starts at the bottom, so I'm looking for the lowest point on the graph, which is this point right here. And if I look, where does that hit my y-axis? It's going to be right at 0. Okay, so it starts at 0. And then if I keep going, I want to see what is the highest point of my graph. Well, this arrow, it's not only going to the left, it's also kind of going in the upward direction. Since it's at an angle, there's going to be higher and higher points if we continue on that curve. So the range, it's starting at 0, but it's going to go up to infinity. So from 0 to infinity. Okay, so that's domain and range like we talked about last class. Today we're going to add on one more way of describing a graph, and that's going to be end behavior. Okay, so when you talk about end behavior, you're basically describing what happens on the endpoints of the graph. So if I look, say, at graph C, we could say that the end behavior is that it's pointing upward or going to infinity on both endpoints. Whereas if I look at graph D, I could say that the end behavior is on one side it's going down to negative infinity, on the other side it's going up to positive infinity. Or if we say look at graph F, we could say that the end behavior is on both sides it's going to negative infinity. Okay, so that's end behavior, but just like we did for domain and range, there's a notation that we use to describe the end behavior. Okay, when you're doing your notation for end behavior, you need to first describe the end behavior on the left, and then you need to describe it on the right. Okay, so for this first graph, we can see that on the left, it's going up to positive infinity. Okay, so the way that we would write that, instead of saying left, we're going to write as x goes to negative infinity. Okay, since the negative numbers are on the left side of the graph. So when I say x goes to negative infinity, we're talking about going to the left on the x-axis. So we would say as x goes to negative infinity, well, what's happening is my function is going up to positive infinity. So what we're going to call that is going to be f of x goes to positive infinity. And that right there would be how we describe our end behavior. Basically, it says as we go to the left, our function is going to go upward to positive infinity. Okay, then we need to describe the right. So to describe the right, now we're going right on the x-axis. So now x is going to positive infinity. And we can see as we go to the right-hand side that right endpoint is also going up to infinity. So we would say that our function, f of x, is going to positive infinity. And that's your notation for the end behavior. Again, what it means is, as we move right on the graph is going to go up to positive infinity. Okay, now we'll go ahead and look at the next graph. Again, we need to first describe the left of the graph and then the right of the graph. So left, the way that we write that again is as x goes to negative infinity. So as I go to negative infinity on the x-axis, I can see that my graph is going downward to negative infinity. So we would say f of x goes to negative infinity. Okay, so that's the left, saying as x goes to the left, my graph is going to go downward to negative infinity. Okay, then we need to describe the right endpoint of the graph. So for the right, we say instead x is going to positive infinity. So we're going right on the x-axis. And we can see when I go to the right, this right endpoint is going up to positive infinity. So we would say f of x goes to positive infinity. Okay, so again, this notation is just saying as we go to the right, my graph is going to go up to positive infinity. Okay, we'll go ahead now and look at E. Again, notice the first part for my end behavior every time is the same. I'm always writing x going to negative infinity x going to positive infinity. And remember, those are representing the negative infinity represents going to the left. The positive infinity represents going to the right. Okay, so we're looking at what would happen if I go first to the left on my x-axis. Okay, well, I can see as I go to the left, this graph is going lower and lower, but then it kind of just gets straight and it flattens out. It's not going to go down to negative infinity. It's stopping right here at 0. So we would say, as we go to the left, our function value, f of x, goes to 0. And it's just kind of stopping at 0. It's not going to continue to go down since it's flattening out and getting straight. Okay, and then we do the same thing for the right-hand side. If I go right on the x-axis, I can see that this other endpoint of my graph is going up to positive infinity. So we're going to say f of x goes to infinity. Okay, but then again, the way that we're reading this is we're saying, okay, x goes to negative infinity. So we're saying as we go to the left, my graph is going down to 0. And as I'm going to the right, my graph is going up to positive infinity. Okay, we'll go ahead and look at one more example here. So now same thing, always starting off the same by going, what happens when x goes to the left, and what happens when x goes to the right. Okay, so going in the leftward direction, I can see on the left side my graph is ending right here at negative infinity. So we would say our function value f of x is going to negative infinity for the left side. And then for the right side, you can see if I go to the right, on the right hand side my graph is ending down here at negative infinity as well. So we'd say the function value f of x is going to negative infinity. So as x goes to negative infinity, going in the leftward direction, my graph is ending at negative infinity. As I go to the right, my graph is also ending at negative infinity. You can go ahead and turn over your page to the other side. Kind of a summary of what to look for when you're looking at end behavior. So first thing I want to point out here is end behavior. You're really only going to look at graphs where you have arrows on the ends. Okay, you're not going to really be finding end behavior if you're ending with, say, a closed circle or an open circle. We're only going to look at the graphs where they end with arrows. Okay, when you're looking for the end behavior, you're basically answering two questions. You're first answering the question, what's happening as your graph goes to the left? Okay, but the way that we write that the graph is going to the left, or that you're looking to the left of the graph, we say x going to negative infinity. Basically saying you're looking at the negative side of the x-axis. Okay, and then so when we look at going to the left, you're basically checking how is that graph ending. So you're looking at the arrow and asking, okay, is it going to positive infinity or is it going down to negative infinity? Well, if it goes up, it's going to positive infinity, so we would say that the function f of x goes to positive infinity, whereas if it's going down, we would say the function f of x is going to negative infinity. Okay, so that's the first question. We're saying if it goes, looking at the left-hand side of my graph, does it go up to positive infinity or does it go down to negative infinity? Okay, and then we do this right-hand side of our graph. So when we're looking at the right, the way that we denote that is we say x is going to positive infinity. Okay, but then we check for the same thing. We look at the right endpoint of the graph and we say, is it going up? In which case it would be f of x going to positive infinity. Or is it going down, in which case it would be f of x going to negative infinity. Okay? Most of the graphs you're going to see, it's going to be either positive infinity, negative infinity. Occasionally, back to that last example, you'll have one like part E where it doesn't quite go to negative infinity, it just flattens off, and in that case we said it's just going to 0. It's going to stop there. It's not going to get smaller from that point. Okay, so we'll go ahead and look at a couple more examples on these ones. I'm going to do all 3 parts, and that's what you're going to actually do today on your assignment. You're going to be asked to find the domain, the range, and the end behavior for each graph that you're going to be looking at. Okay, so I'm going to go ahead and start off with the domain. So recall that when you're looking at the domain, you're basically deciding how far to the left does my graph go. So I can see here on the left side, my graph has an arrow that's continually pointing in the leftward direction. So my leftmost point here is going to be negative infinity. And I'm just writing out, this will be here in interval notation, and then I'll also do the inequality notation. So leftmost point, it's never stopping, it's going to negative infinity, but on the right, it's also never stopping, so it's going to go to positive infinity. So that would be interval notation, inequality notation. We would just write starting at negative infinity, ending at positive infinity. X is in between the 2 infinities. Okay, so that's our domain. Now for your range, recall that for the range we're basically describing how far does the graph go, starting at the very bottom of the graph, going to the very top of the graph. Okay, so here for our range, the bottom of my graph is right here at this point. Okay, and range is describing the y-axis. So I'm looking at that point and I'm seeing where is it on the y-axis. So we can trace back and I can see that this point lines up with 3 on the y-axis, and actually negative 3 on the y-axis. So we would say that the bottom of our graph is at negative 3. And then we want to keep going to find the top of our graph, but since these arrows are kind of slanted, they're pointing upward, there is no top of my graph. It's just going to keep going and going forever. So my range ends at positive infinity. Okay, and again, that's interval notation. Okay, for inequality notation, it's going to look like this. Okay, now I'm doing range, so instead of x, it's going to be y. And y is in between the 2. Okay, but we talked about this yesterday. Whenever you have a number and an infinity, you don't really need the infinity. You can instead just include the number portion of your inequality. So we're just going to write this part right here. Okay, but we typically start with the letter and then have the number. So we're going to have y and then the negative 3. I just want to make sure that my sign opens to the same part. So it's still going to open to the y. And there is my inequality notation. So that there would be my final answer for my range written in inequality notation. Okay, so that's domain and range. Now finally I'm going to go to the end behavior for the same graph. And since I have some extra space over here on the left, that's where I'm going to write my end behavior. So from what we have up here above, end behavior, you're basically answering two questions. The first question you're answering is what happens to the graph as it goes to the left? So what happens as we go to the negative side on the x-axis? And I can see here on the negative side, this endpoint on the left is going up to positive infinity. So we would say f of x goes to positive infinity. Okay, that's the first part. Then we want to do the same thing for when x goes to the positive side. So on the positive side, this other endpoint is also going to positive infinity. So we would say f of x goes to positive infinity. And that's my end behavior. Okay, same thing for example 2. We're going to do all three parts, domain, range, and end behavior. And I know I am taking quite a bit of time writing out every single little part as far as the two different notations for both domain and range. Part of the reason I'm doing that is today when you get your assignment, I am expecting you to go ahead and show me that you know how to do each one just for practice. And a little later on, I will eventually accept either one, but for right now I am expecting that you continue to practice both of them for today's assignment. Okay, so now looking at number 2, again we'll start with domain. So intervals. Okay, so I'm looking at how far to the left does my graph go. Okay, so if I look at this arrow, it's pointing upward, but it's not perfectly straight upward. It's kind of going a little bit to the left. So what's going to happen is I continue this, and little by little it's going more and more left. It's never going to end. It's continually going to negative infinity on the left side. So for our domain, it's starting at negative infinity, and we have something similar here on the right-hand side. It's going to go to positive infinity. Since it's not perfectly downward, it's also going off to the right. Okay, and then for our inequality notation, it's also going to be from negative infinity to positive infinity. And this is where we put our x in between, just like that. Okay, now our range on this one's actually going to be the same. Since I have arrows pointing down, my lowest point is going to be negative infinity. It's also never going to stop in the upward direction. It's going up to positive infinity. So for our range, we would also say that that's going to be from negative infinity to positive infinity. And then for inequality notation, it's going to be the same thing. Only difference is now instead of x, we're describing top to bottom. So we're moving along the y-axis. We're going to say that y is in between negative infinity and positive infinity. Okay, and now the only part that we have left to do is the end behavior. End behavior, again, recall that we're basically describing two parts. First, what happens as we go to the left or to the negative side of the x-axis. So now we're looking at this endpoint. So what is the end behavior on the left side? So we would say as x goes to negative infinity. Well, here I can see my left endpoint is going up to positive infinity, so we would say f of x goes to infinity. Okay, then we need to know what happens as we go in the positive or in the right direction. So looking at our second endpoint on the right-hand side. Okay, and notice this graph's a little different, how my endpoint isn't actually on the positive quadrant of my graph. It's still here in the negatives, but we're still going to consider that one where x is going to the positive infinity. Okay, because remember this part just means the right endpoint. So when I look at this is the right endpoint as opposed to the left endpoint of my graph. So we can see that that right endpoint, so as we're going to the right, my function is going now to negative infinity. And that would be my end behavior for the graph. Okay, and that's going to be it for your notes for today. Don't forget to go ahead and take a picture of your notes that you've written on your handout, and then you're going to go ahead and submit that picture to Google Classroom.